Hello everyone, welcome to Equal To, and this is the first video of class 9 CBSE maths, that is number systems. So it's the chapter 1 and this is just the introductory chapter. It doesn't have too much complicated concepts, but we are just getting started and getting the basics right. Okay, now we first start with a number line. Number line is something that you would have learnt in your lower classes. Okay, so here we have a number line which has 0 at its middle, and to the right of it we have 1 by 4, 1 by 2 and 1, and to the left of it we have minus 3 by 4, minus 1. So it's just a 1 by 4 interval. Okay, so now we have this number line. Now in this number line you could see that we have a 0, we have 1, and we have some fractional numbers which is 1 by 4, 1 by 2. We also have negative numbers minus 1 and negative fractional numbers like minus 3 by 4. Now these numbers can be natural numbers, they can be whole numbers, they can be integers, they can be rational numbers. Now these are the 4 things that we are going to see in this video, and we'll be seeing what exactly these things are and what they mean to you. Okay, now we are going to see what these things are. Now first we have what we call as natural numbers. So what exactly are natural numbers? So natural numbers are numbers that start with 1, 2, 3 and it goes on, right? From 1 to positive infinity plus infinity, we call those numbers as natural numbers. So it's like 1, 2, 3, 4, 5. It's quite obvious, right? I don't have much to explain here. It's just 1, 2, 3, 4 up until positive infinity is what we call as natural numbers, and the symbol to denote natural numbers is uppercase n. So uppercase n denotes natural numbers. Now we are moving to the second type of numbers that we are going to see, which is whole numbers. So whole numbers are similar to natural numbers, but they have one more number included in them, which is 0. So whole number starts with 0. So 0, 1, 2, 3, 4, 5 up until positive infinity is what we call as whole numbers. So in simple terms you could say whole numbers are natural numbers added with 0 is what we call as whole numbers. Okay, now I hope this is clear, and the representation for whole numbers is a uppercase W, and that is how we represent a whole number. Now moving on, we have what we call as integers. So what are integers? Integers are quite similar to whole numbers, but not exactly so. Okay, so the numbers that are included in integers are 1, 2, 3, 4, 5 and those positive side, and also the negative numbers minus 1, minus 2, minus 3 up until minus infinity, those negative side, and also the 0 that is included in between. So all these numbers come under the category of integers. Okay, so non-fractional numbers starting from minus infinity up until plus infinity, everything comes under this category called integers, and the symbol for that is Z. Okay, the symbol to represent integers is Z. Now moving on, we have another term that is called as rational numbers. Okay, now there is a definition, there is a clear definition, worded definition for rational numbers. For the above these 3 things we were just explaining with some examples and little bit of those things. Now for rational numbers we have a proper definition, which is rational numbers are numbers that can be represented in the form of p divided by q, where both p and q are integers and q not equal to 0. Now these are the things that should be maintained in order for it to be a rational numbers. So what are given here? So the number should be represented in the form of p by q, p divided by q, it should be represented in that form, and in that case p and q should be integers. So this is one thing that you are going to note here, p and q are integers. And one more important thing that is going to be key here is q not equal to 0. Okay, so these are things that you have to note. Okay, now let us take a few examples and see if those are rational numbers. Okay, now minus 25. We know minus 25 is an integer from what we saw already, right? Like what we saw previously, the definition of integers, all negative non-fractional numbers are integers, right? So minus 25 is technically a integer, but minus 25 can be represented in the form of p divided by q, where both p and q are integers. Okay, now minus 25 divided by 1 is obviously minus 25, and that minus 25 divided by 1 is actually in the form of p divided by q, isn't it? Now this is minus 25 divided by 1, and that is in the form of p divided by q, where that 25 here is the p and the 1 here is the q, and q obviously is not equal to 0. So this is of the form p by q, where q not equal to 0, and hence minus 25 is a rational number. Okay, now I hope you are clear with that. Now similarly, you can tell positive integers also are rational numbers, and also 0 is a rational number because 0 divided by 1 is 0, and hence it is a rational number. So you can say all these things are rational numbers. And also, for example, let us take 2 divided by 3. 2 divided by 3, here 2 and 3 both are integers, we know that, and q is not equal to 0. So hence q 2 divided by 3 is also a rational numbers. So the definition for rational numbers is that you can express it in the form of p divided by q, where p and q are integers and q is not equal to 0. Okay, now this is the definition for rational numbers. Now you can observe something. Natural numbers start with 1 and go up till positive infinity. Whole numbers adds on to that and adds a 0 in front, and it starts from 0 and goes up until positive infinity. And for integers, it starts from negative infinity and it goes all the way up to positive infinity. So it includes whole numbers as well. And rational numbers, it has all the integers and also fractional numbers that can be represented in the form of p divided by q, where q is not equal to 0. Now you can observe that it forms this kind of a structure. Okay, now rational numbers is the enclosing set. Okay, set, you don't have to complicate about set, it's just a collection. Okay, now rational numbers includes everything. Rational numbers includes natural numbers, whole numbers, integers, everything comes under rational numbers. Whereas integers include whole numbers and natural numbers, both these are integers. Whole numbers include natural numbers in it. Okay, so these are just going to add things onto them as they come out. So natural numbers when added with 0 gives you whole numbers. Whole numbers when added with negative counterparts give you integers. Integers with having integers, if you add fractional numbers as well, you get rational numbers. Okay, so it's a rational numbers is a collection of all these things. I hope these things are clear for you now. Now moving on, we have an example question. Now I know this is an example question and you have the solution for this in your textbook, but let me just explain it to you so you could understand it better, and there shouldn't be a reason for you to take your book. These videos should be more than enough for you to get very good grades in your exam. I will cover every single thing that is important for you and your exams, so don't worry, and we are going to see this example now. So, are the following statements true or false? Give reasons for your answers. Okay, and we have 3 subdivisions here. So let us take the first subdivision, which is every whole number is a natural number. So this question can be answered with the concepts that we saw just now. So is this true? Now whole numbers include 0, 1, 2, 3, so on up until positive infinity, and natural numbers include 1, 2, 3 up until positive infinity. Okay, now you can see that we have already seen whole numbers is equal to just natural numbers added with 0. So this is what whole numbers is. Okay, now with this said, we read this question once again. Every whole number is a natural number. Is it so? Every natural number is present in whole numbers, because starting with 1 up until infinity, this is just natural numbers. Okay, so every natural number is present in whole numbers, but every whole number is not present in natural number, because 0 is a whole number, but 0 is not present in natural numbers. So it is not true. This is false. Why is this false? Every whole number is not a natural number because 0 is a whole number and that is not a natural number. Now we are just moving on to the second subdivision here, which is every integer is a rational number. So is this true? Now every integer, in the sense integer is represented by z and it's from negative infinity to minus 1, 0, plus 1, plus 2 up until positive infinity. So this is what we call as integers, right? I am just going to erase these things so it's better for you. Okay, I hope it's clearly visible now. Yeah, just to create a separation. Okay, now in the second subdivision we are seeing that is every integer a rational number. So integers start from negative infinity and go all the way up to positive infinity, and rational numbers, which is represented by q, we have seen that, and it includes integers as well as fractional numbers. Okay, now rational numbers include integers because rational numbers is just p by q where q not equal to 0 and both p and q are integers, right? P and q are integers. Okay, now I have just represented in short form, meaning z meaning integers. Okay, now we know that every integer can be represented in the form of p by q because whatever integer you take, let it be 5, let it be 7, let it be minus 21, all these can be represented in the form of p divided by q just by representing it as divided by 1. Okay, divided by 1 meaning it's the same number, but q also is an integer, so it's in the form of p divided by q, and obviously 1 is not equal to 0 and hence all these are in the form of p divided by q. All these are in the form of p divided by q where q is not equal to 0. So all these are in fact rational numbers. So the second statement here is true. Okay, so I'm just going to clear this what you have written already to make space for the third subdivision. Okay, now we are moving on to the third subdivision here, which is every rational number is an integer. Okay, now this is just a statement which is converse to the previous statement. Okay, in the previous statement we saw every integer is a rational number. Now here they are saying every rational number is an integer. This obviously is false. Why is that? Let us say 2 divided by 3. 2 divided by 3 is obviously a rational number. Why is that? It is in the form of p divided by q where p is equal to 2, it should be lowercase q, uppercase q is rational number itself. Okay, where q is 3 and 3 is obviously not equal to 0. So these are the 3 cases and all these 3 are valid in this case, which is 2 by 3, but 2 by 3 is not an integer. Okay, obviously 2 by 3 is not an integer because integers have only non-fractional numbers. 2 by 3 is a fractional number, so it is not a integer. So this thing is false. Now in this example we have answered 3 questions, and what we have done is that we have taken examples to prove if it is false, and we have also taken examples to prove that it is true. Okay, so in the first case we had to prove every whole number is not a natural number because 0 is an example. So if you just say one thing doesn't fit the rule, it means the entire statement is false. Okay, so since 0 is a whole number and it is not a natural number, the statement itself is false. And every integer is a rational number because every integer can be, every single integer possible can be represented in the form of p by q, and q not equal to 0, and p and q are rational numbers. So hence it is true. And also every rational number is not an integer because any fractional number is clearly not an integer. So that is false. So I hope that is all for this video. If you have any doubts, please post them in the comments. I'll get back to you as soon as possible. And in the next video, we are going to see a second example of this, which is a bit more complicated than the concepts that we seen in this video. So stay tuned for that. See you in the next video. Bye for now.